Okay, let's go ahead and get started. So with the first one, I'm starting with 138. I'm going to do 139 and 140 in this video. There's only one that I'm confused with because you say it's no calculator, and that's actually the first one, which is hilarious. There's a simple answer that I know exists, but like doing this by hand is impossible. Because this number isn't like sitting on the unit circle. It's not something that we could just look at. It's not going to be a really common angle. But what we can do is think about, does it exist? And that's a really easy question to ask. So we know that cosine as a graph starts up top, goes down low like this, and it lives in between -1 and 1. So the answer to a cosine question can't be bigger than 1 or less than -1. And we know that 3/4 is somewhere here. So I know it's going to have two answers within cosine, so this 3/4. So the answer to this, like, would be sometimes, and I guess the answer maybe they're looking for would be if I take the inverse cosine. I don't know if you do this notation, cosine -1, or if you do like the arc cosine of 3/4. I hope you know at this point that both this and that are the exact same thing. So I'm probably just going to use this because that's what I use in class mostly. That this is essentially the answer, that x is equal to inverse cosine of 3/4. So what that does is it gets you those answers. So I guess the answer is sometimes. But that's the only one I'm a little bit confused on just based off the fact that you said you're not allowed to use calculators. But I do know that it will have answers, and if you type this into a calculator, like, it'll pop up. And I know just based on that. And while we're thinking about this graph, I'm going to go ahead and do this question a little bit out of order. So once again, I know that sine lives in between 1 and -1. Now, sine equals 5/2. This says, like, when does my sine function equal 5/2? 5/2, as we know, is 2.5. And my wave is never going to go up that high. So this is never. So sine will never equal 5/2. That's because we know that the range of sine is, I should say y, 1 to -1. And I guess if you're justifying, we could say that the range is 1 to -1 of the cosine question as well. So I know that it will have answers. So let's go back up to B now. And to answer B, we need to think really about what tangent is, because we know when we're solving for trig stuff is I want to get my trig function all by itself. So I want to get tangent by itself. So I'm just going to start by dividing both sides by 2. And on the right, this just equals 0. 0 divided by 2. So I get tangent of x equals to 0. So this means when is my tangent equal to 0? Which we know tangent is equal to y over x. So in order for this, well, I should say this to equal 0, my top needs to be 0. So really the question I need to ask is, when does y equal 0? And we know if I just throw up a really quick axis and maybe a mini unit circle, my y is equal to 0 when I'm up top and down low. So that's pi over 2 and 3 pi over 2. And let me read sometimes, blah, 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 give the x values that make it true, always true. So this is sometimes true, depending on your x values. And the x values that would make it true is pi over 2 and 3 pi over 2, and then every full rotation. So when I'm answering this, I'm going pi over 2 plus or minus 2 pi n, and 3 pi over 2 plus or minus 2 pi n. Now the one thing, and I don't know if your teacher does this or not, my students actually don't need it for the AP test, so I don't teach them. But we can notice that these two angles are equal distance from one another, so we can combine these two ideas. So if I start here, going down to the bottom angle is only 180 degrees, and going bottom to top is only 180 degrees. And that's the same thing as pi. So if I just keep adding pi, I'm going to bounce between these two angles. So it would be like 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, that sort of thing. So I can simplify this as pi over 2 plus or minus just pi n. So it's basically saying I could start here, and every half rotation around, I'm going to get another answer. Now the trickiest one is probably D, because you kind of have to like think outside the box a little bit. We have a formula that looks really close to this, and basically I don't actually think you have it written down on the formula sheet, but you have something really, really close to it. Basically, when I looked at this, I know that sine and cosine are related. They're very close to each other, and we know this if like you graph both sine and cosine and you shift one over just a little bit, they land on top of each other. So that's immediately where my brain went with this. And I know, stupid bell, I know if I shift over sine or cosine pi over 2 or a quarter of the way around the unit circle, they're going to land on top of each other. So that's what made me think about this. So I wanted to write it as cosine of x over 2. So this just basically means I take whatever my angle is and I shift it over a teeny bit. Now the way to rewrite that is I got to factor out a negative. So I just pull the negative out of the x, that creates it, make it positive, and if I factor out a negative from a positive number, it just becomes negative. You can think about just what would happen if you distribute that negative back in. You'd get exactly this, just in a different order. Now, one thing that you did have written on that sheet is that cosine of x is equal to cosine of negative x. So the negative version of this is the same thing as a positive version. So then we could get that sine of x equals cosine of x minus pi over 2. And this right here, this is like an absolute fact. It wasn't on your sheet. You had something very similar. Let me see if I could pull it up. Or I guess you could look at it too. Yeah, you have sine. I'll just write what you have, and we could see how similar it is. You have sine of negative x is equal to cosine of pi over 2 minus x. So you can see how similar outside of a negative that is to that. To prove this, you could use, and I think I don't know if you actually did this or not in class. Maybe you didn't take a picture of it. You could use sum/difference formulas of sine and cosine to figure out that you get exactly that, but I won't have to go ahead and show that. So 139 says we're going in between 0 and 2 pi. So let me write that 0, x, and 2 pi. So I want to find all the solutions that are between 0 and 2 pi. And I kind of mentioned it before, but whenever you see the word solve, that means I want to isolate my variable. And in order to isolate your variable in something like this, first I got to isolate my trig thing, and then I do inverse. So first thing I'm going to do is divide by 2. Divide by 2. So I got cosine of x is equal to 1/2. And now I want to isolate my x. So I'm going to do cosine negative 1. Just inverse cosine on both sides. And my cosines cancel out, so I'll be left with cosine negative 1 of 1/2. And this question asks, so I always tell my students, like, what does this mean? Cosine is in terms of x and y is x. So basically what this asks is when is x 1/2? So when is my x value 1/2? So what I need to do now is just draw up a real quick XY graph, and this is what I do every time. And I think about where my x value being 1/2 is. And I know on the unit circle, that's the ones that are going straight up. If we remember the middle ones, this is like the root 2 over 2's. That's not what I want. And the way that I remember how it's not 3 over 2, because this one's root 3 over 2 for the x, and this one's 1/2, is that root 3 over 2 is larger than 1/2. So the x value that's larger, you can see this x portion is larger, than this portion here at the bottom. So that's how I know this one's going to be the answer. And I know that this happens at pi over 3 and 2 pi over 3. So my answer has two different x values. So I know that when my angle is pi over 3 or 2 pi over 3, we are going to have that solution being here and here. And you could plug that into a calculator just to check as well. So that's a slightly more simple case. Stuff like this is going to be a little bit trickier, but let's look at the tangent one first. So once again, I'm doing the same thing. I need to get my tangent by itself. So I'm going to subtract 4 on both sides. So I'll get -4 is equal to 4 tangent of x, and then divide by 4, divide by 4, 4 divided by 4, and it's negative is -1. So tangent of x equals 1. Now, here is the fun part. So tangent is y over x. So when my y over x equals -1, let's just forget about the negative. When it equals 1, that means the top and the bottom are exactly the same. So whenever you see tangent is equal to 1 or -1, you know it's going to be one of the pi over 4s. So this is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And we know this because at all the pi over 4s, it's root 2 over 2 and root 2 over 2. One of them is positive and negative, but they're both the same number value. So if I put y over x on top of each other, it's going to be 1 because it's root 2 over 2 over root 2 over 2. So anytime you see 1, you should automatically think pi over 4 is for the tangent. Now, how I know which one is which is with the negative is I know in quadrant 1, they're both positive. So this would result in a positive tangent. And then over in quadrant 3, we would have a negative root 2 over 2 over negative root 2 over 2. So that would also result in a positive number. So whenever tangent is negative, we're talking this quadrant, quadrant 2, and quadrant 4. So I know my answer then is x is equal to 3 pi over 4 and 7 pi over 4. So those are the two answers to that. Now, letter C, this is probably the trickiest problem. That's because it looks really weird. So I'm going to kind of explain what's going on, and then I'm going to put it in simple terms, and we'll go back to using signs. But let's look at the issue we have. Dealing with a sine squared by itself is cool. That's calm. Get the sine by itself, take the square root of both sides. That's cool. But if I have something squared and then just another one by itself, like that's tricky. So what I want to do is I'm just going to pretend that sine of x equals x, and we're going to go ahead and work like that. So I'm going to go 2x squared minus x minus 1 equals 0. So let's go ahead and just look one more time at what I did. All I did was change sine to x. Change sine to x. So 2 sine squared minus sine minus 1. And what I would do here then is just factor. So I got to do factors of AC. So it's 2 times -1. That add up to my middle number. So factors of -2 that add up to -1 or -2, positive 1. I don't know what factoring strategy you work. I know there's like 8 trillion if you do slip and slide or something like that. But basically all we're doing is factoring and then factoring by grouping. So 2x, so this x, this 1x would be split up into -2x and positive 1x minus 1. And then we go ahead and factor. So 2x gets factored out of there, x minus 1. And then nothing can be factored out of here, so I'm just going to bring out a 1 to make it easy. And I'll be left with x minus 1. So I know when I factor this completely, I'll get 2x plus 1 and x minus 1. That's equal to 0. And now I know if I were to go ahead and solve this, I just set each of my little parentheses equal to 0, and then go ahead and solve. So the idea is exactly the same with this. And you could do two things. One, you could do all of this factoring crap with a sign instead of like the x. Or what you could do at the beginning of your problem and in your mind, just say let sine of x equal x, and then just substitute that back in at the end. When you get into calculus, there's going to be a little bit more of this substitution idea. So it's actually not too bad to get working with that now. So we're making it simpler, kind of for your brain. And then at the end, well, I know that 2 sine of x plus 1 is equal to 0, because I'm just substituting that back in, and sine of x equals 0. So we actually already did this exact problem. No, we didn't. We did cosine. So I got sine of x is equal to negative 1/2. So when I think about my unit circle, I got to think about when my y value is negative 1/2. So I know that's going to happen at these like more shallow angles because I'm going down a small amount. And the shallow ones are always the pi over 6s. So 11 pi over 6 and 7 pi over 6 is my answer here. So x is equal to 7 pi over 6 and 11 pi over 6. And then my other answer is just one is that true? Oh, oops. I got to bring that negative 1 over. My bad. So that would become 1. And when sine of x equals 1, we know that we are up top when my y value equals 1. So that's just going to be x is equal to pi over 2. So those are your answers. That's definitely the trickiest problem on here, in my opinion, because of the factoring idea. We can treat sines, cosines, tangents just as like normal things that we would factor with. But when you're first learning how to do it, it's kind of a pain in the butt and it's a little bit not straightforward. So that'll require some practice. Lastly, with D, listen, I don't ever use cosecant in my classes. I don't teach my students to use cosecant. I don't want them to memorize what it is on the unit circle because they already have the sines and the cosines memorize what's on the unit circle. So what I say is, dude, we know that cosecant is equal to something that we do know. It's 1 over sine. So if I write it like this, now I just basically have to solve this equation, which is really not that bad. What I need to do is get sine of x by itself, but first I need to get it out of the bottom of my equation. So I'm going to get sine of x. I'm going to multiply it on both sides. And what that's going to do is it's going to get that sine of x out of the bottom and onto the top. So just rewriting it, I got 1 is equal to negative 2 sine of x. And now if I just divide both sides by negative 2, I'm going to get negative 1/2 is equal to sine of x. Oh, hey, look, we literally just did that down here in the bottom left. So it's 7 pi over 6 and 11 pi over 6. And that is, oops, not sine. That's my x value. I guess I skipped a step on both of these where you would do sine negative 1. Sine negative 1, you do it here and you do it there. But I think hopefully you get the idea and the gist of what's going on. This type of problem is really tricky. If you need more help with something like this, let me know. Also, if your factoring strategy isn't the same as mine, I use factoring by grouping. I know that the Algebra 1 classes at my school uses some slip and slide technique that I've never heard of until this year. But whatever factoring technique you use is fine. You're still going to get the same answer. I don't think anything else was too crazy. This is how I teach, like with, drawing up the little quadrants and stuff like that. How to solve these problems if you're a teacher or you do something different, that's fine. That's just kind of how I use the unit circle, because on my tests, I don't give my students like a filled in unit circle. They have to kind of memorize it because for AP, they won't have it. Anyway, so let me know what else you need. I'm going to make the next oh, shoot, I said I was going to do 142. Let me do that one really quick because I just saw it up on my screen and I was thinking about the solution. So 140 says cosine of theta. This is the important part, and I know you'll probably have it up. And then it also gives us a circle Holy smokes, that's a scary looking circle. Nice. So it gives us a circle, and then the really, really important information is it tells us the hypotenuse is 1, and it gives us that this is the angle. So it basically says, what is this coordinate point? So what I need to find is an x value and a y value. Now, the important piece is what is cosine in terms of x's, y's, opposites, adjacents. So I know that cosine of theta is equal to 1/3, which is equal to the adjacent side over the hypotenuse. So if I were to redraw this triangle that's up inside, I know that my adjacent side is 1 and my hypotenuse is 3. So this is true for this theta as well. But what it tells us is that the hypotenuse is 1. So what we need to use is similarity in triangles and think about scale factors. So it tells us that our hypotenuse is 1. So I got to think, what math do I have to do to get from here to here? Well, we can see that I divide by 3. So I need to divide by 3 here as well. So 1 divided by 3, as we know, is 1/3. So in this triangle, my x value, this bottom part, is 1/3. How do I find what this y value is in red over here? Well, we know that these are all right triangles. Sorry, I didn't put that there. I could use Pythagorean theorem. So 1 squared equals y squared plus 1/3 squared. So 1 is equal to y squared plus 1/9. Subtract 1/9 on both sides, so I'll get 8/9 y squared. And if I take the square root of the top and the bottom, I'm going to get root 4/3. No, not root 4. Excuse me. Root 8/3. And I don't know if your teacher wants you to simplify this radical, but we could split it up into root 4 times 2. And then rewrite this as root 4, root 2/3, and then finally 2 root 2/3. So I think this is probably more what he or she is looking for. So my final coordinate, my final answer for this is going to be 2, 2 root 3. Oh, nope, that's my y value. That's my y value. And my x is 1/3. So, maybe there's a slightly easier way to do it, and just by recognizing the fact that this is a unit circle, so you know that this is the x, and you could jump straight to writing that's 1/3. I just thought about that now and not have to do the similarity piece, but that would be only if this is 1. If this is 7, that whole idea gets all junked up. So I'll do the rest of them later. I gotta go do crap, unfortunately. I'm employed. It's terrible. All right, let me know if this helps. And if you still have questions on any of them, I can run back over them.